So here in the previous examples, if you see, for your up counter, in order to do up counter in your negate triggering, we have connected the Q output. So the Q output I have connected as a clock signal to the next flip flop, right? If it is your up counter. If it is your down counter, what I have done, I have connected the Q bar output I have connected as a clock signal to the next flip flop. So ultimately, whatever the output are there, the previous flip flop output I am connecting as a clock signal to the next flip flop. Now, which output I am connecting? Is it positive form of output or negative form of output? Based on that signal, it will be doing the up counting and it will be doing the down counting. So with this generally what we can say, if you are connecting the Q output, then it will be doing the up counting operation, right? So here if you see, if I am connecting the Q as my clock signal, it will do up counter. If I am connecting Q bar, right, Q1 bar, if I am connecting, it will do down count. Now what I will do, I will design one circuit. Let's say I'll take my JK, this is my Q1, this is my Q1 bar, JK, Q2, Q2 bar. Okay, now if I connect this as a clock signal, this will be my up counting. This will do up counting. Now instead of that, if I connect like this, if Q bar, if I am connecting as a clock signal, then that is going to do my down counting. Now what I'll do is, let me first write all this. Clock of negate I'll connect, input will be 1. So even here I will give input as 1. Okay, now here if you see, I can connect this to this particular clock signal if I want up counter, and if I connect this, it will do the down counting. Now in between this, I have to just manage, I can just take one combinational circuit, right? I can take a combinational circuit. Now for that circuit, I will give one control signal. Let's say I'll give one signal will be there, which will be controlling the operation of this particular combinational circuit. I'll write C. Okay, this is the combinational circuit. I have to develop one combinational circuit, and it will have inputs will be there, it will have outputs will be there, and it will have a control signal also. Now based on this control signal value, I am going to connect either Q1 or Q1 bar based on the control signal value. Let's say if I am giving 0, this Q1 should be connected. If I am giving 1, this Q1 bar should be connected. So likewise, I have to design my counter. Now for that case, what combinational circuit can we use? Can you tell me?
Sir, mux.
Mux we can use. Yes, we can use multiplexer. So here if you see, in between these two, I'll have two flip-flops will be there. I'll take 2 to 1 multiplexer. As we already know, I'll have, right, two input. This is my 0, this is my 1, this is my select line, and this will be my output usually. Okay, now here what I will do is, whatever the Q1 bar. So if I want to connect this, I'll be connecting to 0, this I'll be connecting to 1. Okay. Now whatever the output I'm having, this I'll connect as a negate trigger into the next flip-flop. Now what happens if I want up counting? If I want up counting, what I have to connect Q1, I have to connect to, in order to connect Q1, this particular line should be given to your output line. So that's why the value 0 we have to give at your S, right? If you are giving S is equals to 0, right, S is equals to 0, it will do up counting. Now if you want down counting means, Q1 bar you have to connect, Q1 bar value, like this line value is 1. So if you are giving S is equals to 1, this Q1 bar will get connected and it will do your down counting. Okay, so let me write the neat circuit. Just make a note of this one. Here I will take one multiplexer. This is my J, this is my K. Q2 high. So this is my 0, this is my 1. So this is my S. Now based on this value, we can just do up counting also, we can do down counting also. For that, how you will implement this? First of all, you should have a truth table, right? If I write a truth table for this, yes, Q1, Q2, and let's say Y. Okay, this I'll take it as a Y or some wire you can take. Now if I write the input combination 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Now here, if your select line value is 0, right? If your select line value is 0, that means up to here. If your select line value is 0, your Q1 should go to your output. So whatever the Q1 values are there, simply you write all these values. And when your S value is 1, this Q2 should go to your output. So I will be writing the Q2 values 0, 1, 0, 1 as it is. Now instead of your multiplexer, we can also take that AND functionality, we know, right? So we can take two AND gates. So inside your multiplexer, you will be having this functionality only. If you want to write your multiplexer in gate level, then you will have this circuit itself. Okay, the two AND gates will be there, one OR gate will be there. So in place of your this multiplexer, you can put this. Now for this particular input, you can connect your Q, and for this particular input, you can connect Q1 bar. Now for this you can give S, and for this you can give S bar or anything, it is fine. And this will be your Y, which you will be going to connect as a clock signal to the next flip-flop. Okay, between your first flip-flop and your second flip-flop, you can have this also as your combinational circuit. Okay, let me just change the color. In the place of this circuit, you can take this circuit also, it is also fine. If they ask you to take only circuit of logic combination circuit, that you have to construct using logic gates. If they mention that you have to construct using logic gates, then in place of this multiplexer logic, you can simply write down these two AND gates and one OR gate. Okay, make a note of this and let me know once it is done.
Sir, screen is not visible.
Am I audible? Hello? Last year, am I audible?
Yes, sir. Now you are audible. Screen is not visible, I said, sir.
You are unable to see the screen. Vaishnavi, is it same for
Yeah.
you?
Now it is visible, sir.
Okay.
It's visible, sir.
Okay, make a note of this.
Yes, sir.
Vaishnavi, is it done?
Yes, sir.
Okay.